right, so today we are going to look at another alcohol reaction. This is the addition of chloride via thionyl chloride, or SOCl2. That looks like what you can see down there, but it's a double bonded sulfur and oxygen with two chlorides. And so this is a very interesting reagent. There's an area of very low electron density near the sulfur, and of course the oxygen, which is very electronegative, has the majority of the electron density. So it forms a dipole, a very strong one, right here, making the sulfur electrophilic. So just a couple of things about this reaction is it works for primary or secondary alcohols only. It's an SN2 substitution, so there's no rearrangement. Solvent should be aprotic, and the relative rates are primary is faster than secondary. So here's our reagent here. We have an arbitrary alcohol here. Just imagine it's there's an H up there, so this one would be a secondary. And then we get an R and R prime here, which accounts for our primary or secondary. All right, so looking at the mechanism itself, my controller went out. There we are. All right, so inversion of stereochemistry. Similar to other mechanisms, we have a lone pair attacking an area of low electron density. And so that's, as I mentioned earlier, is on the sulfur. You're going to see this very often with carbonyl chemistry. A lone pair on, some hetero atom or a nucleophile attacks an area of low electron density, and then one of the pi bond bounces up to the oxygen, which is very electronegative, so it's fine holding on to this. So it's fine right here. We have a positive charge on the oxygen. That was part of the alcohol, and what happens is that negative charge on the oxygen bounces back down, and these electronegative chloride atoms, one of them pulls off the electrons in the bond here, and we get minus Cl minus shown here. All right, and then this is the SN2 part. Goes in, inversion of stereochemistry, and we get our product plus the thionyl chloride product, which is what would you call that? It's a chloride alcohol thionyl compound. So looking at slightly different example, here we have where above we had a secondary DMF as our aprotic solvent. We have a primary, or benzylic, more precisely, alcohol. So these react even faster, and because it's benzylic, that aromatic ring is going to stabilize some of the transition states. So here's our thionyl chloride. Let's put the lone pairs on our alcohol oxygen, and it attacks the electrophilic sulfur center. Pi bond bounces up to the oxygen, and then we get this intermediate right here. Again, negative charge comes down from the oxygen. One of the chlorides comes off, minus Cl minus. And here, again, we have the SN2 portion of the reaction. And so we get our products here. A benzylic chloride aromatic compound. Anyway, That's all I have for today. Some more alcohol reactions coming soon. Let me know in the comments if this is the kind of thing you want to see or if you want me to work through these problems in a different way. Thank you.